recording. And first, let's finish what we left off from lecture 2. There are three small topics that I wanted to cover. The first one is going back to function arguments. So yesterday we talked about functions that they have positional and keyword arguments. The positional arguments always have to be come before the keyword arguments, and so on. And when we call a function, we can pass the parameters as positional or as keyword arguments. But Python allows even more. So we can actually use a variable number of arguments and keyword arguments. What does this mean? In the functions so far that we defined, we always define the number of arguments, 1, 2, 3, not more, although I showed you the pandas example, which with 25 or so arguments. But we can actually do an arbitrary number. And here's a small example of this. The syntax goes like this. You put an asterisk here, and then you collect the arguments in one variable. This will be actually a tuple. We get the arguments in a tuple. And I also printed the lengths here. So in the first call, let's just comment these so that we have less noise. So in the first call, we have 5 arguments, 1, 2, 3, 4, 5. And then we print each of those. Note that the name args is is usually named like this. So you don't have to do this, but you should actually. There's not much reason to change the name. Change this name. We usually do it this way. One small caveat is that we can do 0 arguments, by the way. So here you have an empty tuple for the second call. But what we cannot do is keyword arguments. So we cannot pass arguments with keywords. This will give us a type error because this function that we called arbitrary positional f got an unexpected keyword arguments. The reason is that this single star only accepts positional arguments. Of course, there is a solution for this. So there is another such collector with double asterisks, which will accept keyword arguments, but only keyword arguments. And it's usually named quarks.
Can I use like none elements to skip one of the arguments? Like if I just need to use argument 1, 2, and 4, can I write like argument 1, 2, none, and 4? Or because none would be then the third argument. Is possible?
Yeah, sure. You want to pass when you call the function? Do you mean here when you call the function?
It's like 1, none, and 2, and then there should still be 3. Yeah, exactly like this.
You can pass none, and it's going to be there.
It's so this like fills in the argument I didn't want to pass. Okay.
No, you cannot do this. That you pass this. If you have like a complicated logic like this, you should pass them through keywords.
Okay.
Like in the pandas example, where almost all arguments were keyword arguments because it's impossible to follow the order. But okay. Of course, you can none is an object just like any other object. Of course, you can pass it as a function parameter. But let's see the keyword example. So we have quarks here, and the type of quarks is dictionary. Why is the dictionary? Well, it's because we get name, argument name, and value pairs. So we have a dictionary here. Its length is 2, and the first argument is 1. The second one, named arg2, is 12. Of course, I could switch up the names. So here this naming convention is so it's up to you. You can use any name here. as long as it doesn't start with a digit. But you can use a name here. This will capture keyword arguments. However, now we cannot pass positional arguments. So if I try to pass, this is a positional argument, the first one, I get an error that this function takes 0 positional arguments, but 1 was given. So what's the solution? We usually capture both of those, both the positional and the keyword arguments. Here is one such function. Again, this does nothing but print whatever it gets. It checks if it got anything, and if it got anything, it will print those arguments. If it didn't get anything, it will not print them. Let's see the first example. In the first call, this one, we don't pass along anything. So there are no positional and there are no keyword arguments. Let's see the second call, which is more exciting. We get positional arguments here, 2 of them, 12 and -2. So these are ordered. 12 is the first one, -2 is the second one. They come in a tuple, which we named args by convention. And we also get one keyword argument, param1, and its value is foo. And this is captured in the Quarks dictionary. One important note that the order cannot be changed. So since positional arguments always come before keyword arguments, we can't change them. So if I try to do this, I will get a syntax error. It's not super helpful, but simply the problem is that I try to switch them up and positional arguments must come before keyword arguments. We'll see more application for this on later on this course, I think on Thursday. Any questions about this? No, then let's move on to the last topic in the notebook and then a demo. I want to talk about lambda expressions. So actually, I already used them in the sorted example. Lambda expressions are unnamed functions. So functions that don't have a name. All the functions we defined so far look like this: the definition, some name, some parameters, and maybe a return value at the end. Some one or more return statements. Lambda expressions, on the other hand, are much smaller functions that we don't name them, and they can only contain one single expression. So, for example, this is a lambda function from here to here. It takes one parameter. We could take more parameters. You could list them here, comma separated. It takes one parameter and it returns one value. And as you can see, there is no return statement here. So because it's implicit, that's the only thing it does. It returns whatever we write here. And we return the lowercase version of this. Why do the lowercase thing here? Because if we sort this list, the sorting does not ignore the case, even though it should be ignored. And I want it ignored, so I will use a key for sorted to do it. Here is one example. We could wrap it in a function and use our function. Here I'm passing the function name. Function point. It's similar to a function pointer in C and C++, but it's not exactly that. It's actually a reference to the function object. And we can pass along either the function, but in the case of such short functions, lambda functions are actually the preferred way. Okay, because then we don't have to look up this function. I don't have to find where it is. In this case, by the way, I could also go string lower. So this is also a possibility. And then all we have to do is pass it without calling it, because this is also a function. So we could pass it along like this.
Excuse me?
Yes?
Does this only work for functions with a single statement, or is there any way to, for example, have two statements in the lambda function?
You could do tricks to do two statements, like you could have it only works with one statement, but you can do tricks like this, and then we get two values because it's a tuple, but still this is one return statement.
Okay, thank you.
Also, I think this is kind of an anti-pattern, what I just did here, because if you use unnamed functions, then it doesn't make sense to save them in a variable. So these are pretty much discarded. So you only use them when you can discard them later on. For example, in this weird sorted printing that we did with the shopping list. Here's an example with numbers. So if we want to sort them by absolute value, we could use the built-in abs function. If we want to sort them by their modulo 3, we could say that this is the function that they should use. I don't see a good application for this, but yeah, you can do it. So anyway, this is a double-edged sword again, as many things in Python. Use them with care. Be careful that your code is readable, because it's very important. We rarely work alone, and we need others to understand what we are doing. Oh, and here are some tuple comparisons, but I think we covered these in great detail, so I'm not going to go here again. And here is some other example. Let's move on to the last topic that I wanted to cover today, type hints, which I'm sure some of you have seen before. So in Python 3.5, they introduced optional type annotations. This is mainly used for function arguments. You can use it for new variables. So what does this mean? We can add types to function arguments, for example, and this is hint, as the name suggests. It's a type hint. It's not mandatory to use this. In this example, I take the name, which should be a string, and the age, which should be an integer, and I return a string. This is the syntax. It's a bit unusual first, but you can get used to it pretty easily. And then I can call the function, and I was nice and I passed along the correct values, but it's not mandatory. So I can pass along other things like this, and so on. But what do they serve? What are they good for? First of all, they are good for documentation. So when you read the code, it's easier to tell what it does and what the parameters should be when you see the type. That's one thing. It's supported by the IDEs, PyCharm and VS Code, and you get the hints as you write the code. It will give you warnings if you don't pass along the correct types, and so on. And there's also a static type checker that I wanted to demo today. I have a short demo here, and actually the type demo is here already, so you can find it in the GitHub repository. I'm just going to open it here. It's a bit small, I realize that. Okay, I hope you can see it now. And if I run this code, wait. I don't see a lot of exciting stuff, but what is more that I want to demonstrate is that there is a static PyChecker called myType, and that will run through all the all the type hints and check if I use them, if I use the functions correctly. And now I'm getting an error, which is not surprising. First, I want to show you a correct run. So there is this bar function. It's not super helpful, but it takes an integer and returns an integer. It will call the foo function, which takes a float and returns none, but it will print this. Let's run it, and we see that foo printed 42 and 43, which is what we passed along here, and that looks correct. Let's see what MyPy has to say. It actually complains about the other function. So happy birthday. But if I comment it, I have to comment this one as well. Then MyPy passes without issues. Now let's make it more complicated. So happy birthday is a new function that takes a string and either an integer or a string. And this is supported via the typing module. So what I import up here from the typing union is going to be either of the types that are in the union. Here I have two, but it could be, we could go any number here. So this will take either a string or an integer and return a string, namely the formatted string of this value. And this is so far correct. Let's try to use it. And as you can see, I'm already getting hints here, which is more helpful than without the type. So I see that it should be a string, and age should be either an int or a string, and I will get a string in return. This reminds me that I should print whatever I get here. So my name is Judith, and let's get here a string, and we can print it since the return value is a string. Let's see what MyPy has to say. MyPy says there is no problem. It's a static type checker, so it's not running the code. Let's see what happens here. And it's wishing me a happy birthday. Now, let's see what call happy does. Call happy is the next one. And here I made a mistake on purpose. What is the mistake? So name is correct. We are passing along name to happy birthday. Second one is age, but age is unfortunately not completely correct since the union here contains 3 possible elements, but happy birthday only takes an integer or a string. So that's why I get this error. It's not always easy to read at first, but if you get used to this error messages, it will get easier. So let's remove the list from here. And let's see what MyPy has to say. It says it's okay. Now let's try to call happy. I'm already seeing an error since it's a list. Let's see what MyPy has to say. MyPy, why isn't MyPy saying anything? I think it's some setup issue. Yeah, MyPy has a lot of configuration, so now it's not telling me that there's a problem, but Vim is telling me there is a problem. And if I run it, it runs without issues, but the resulting string is quite weird. Okay, let's fix this. John is 25 years old. And finally, let's print it all. And here MyPy again found no issue. And with print all, I want to show another option. We have other things imported from the typing module. So we have sequence here, which is an abstract sequence type. Very often we don't need to know if it's a list, a tuple, a set or whatever, we just want to iterate it. So here, the only thing we are doing with is we are iterating it. Actually, it should be a sequence of strings. Sorry. And as you saw, when I enter string, this was immediately underlined because it's not a string here. We could do, instead of string, we could do any here. And any is a wildcard. So any is like giving up. We don't know. It could be anything. And there's another one frequently used, optional. And optional is when you don't need to provide it. So it's an optional string. And optional should always have a default. So if I remove this, I should get an error. Actually, I get an error here because I'm not passing along the optional parameter. Let's try. Let's see what MyPy says about this. It found no issues. But the editor does find issues. Okay, that's all I wanted to say. This is a very basic introduction to type hints. You are not required to use it, but we recommend using it for any code that you share with others. Some companies require the usage of type hints. It's up to the team that you work on, but they are very convenient and they are a good way of making your code more readable and also having some guarantees. No, it's not as well guaranteed as a fully typed language, but we do get some guarantees. Do you have any questions? I will click on the invite link for the second assignment. Let's accept it. And it will create my own assignment repository. Let's clone it. And here's the assignment notebook. And we can get started with the first exercise. Again, we have you have 25 points maximum. There are 3 groups of functions. The first one is string manipulation. The second one is also string manipulation, but it uses the Wikipedia module so that we work on some real data. And the third one is linear algebra. That's a different topic. And I will show you the first function, and then you can work on the rest of it on your own. Define a function that takes a sequence as its input and returns whether the sequence is symmetric. A sequence is symmetric if it is equal to its reverse. Okay, so we could write it, we could do the reversal and compare with reverse, but we can do this by hand. So how do we do this by hand? Well, we have to go through the list and compare with the symmetric element. And if we ever find 2 elements that are not the same, then the list is not symmetric. If we finish this comparison and everything was the same, then the list is symmetric. And that's what we are going to do. I'm going to use the index of the list here, but we only have to go until the middle of the list, because we'll always compare with the last one and we go like this, and the middle element doesn't matter if the number of elements is odd. If it's even, then we get to the middle 2 elements. And if we find any element where it's not the same, then we have to return false. Here we have to think about the index a little bit. So it's going to be we can use -1. You remember that we could do -1, -2, but it's going to be something minus e, but not minus c, but e plus 1. So it's going to be +1, e plus 1. If we are at element 0, then we want to compare it with the -1 index. When we are at element 1, we want to compare it with -2. And if it's ever not the same, so if any of the pairs are not the same, then the list is not symmetric. If we finished going through the list, and all of this, if we never return from here, this means that all pairs are the same, then the list is symmetric. And let's check all the tests, and the tests pass nicely. One common mistake is that people do this, and the tests should check for that. Okay, any questions? I'm gonna give a tip for the second one. So if you have a dictionary and you go through, you can say that this will perhaps help. Okay, if there are no more questions, I will stop the recording.